All right, we're still in Unit 1. We're on Chapter 5, and we were in the last video looking at some box and whisker plots. Showed you how to find them on your calculator, but now we're continuing through this by looking at such things as now how we find some outliers with the data. That's basically where we're at. So, do we just look at the data and just go, oh, there you go, there's an outlier, right? Is 21 an outlier, for example, of the data set? So, most would say, yeah. All right, but then is 19 an outlier? And if you don't remember, I'm trying to go back here to see if we can find our data. I had you plug in, going back pretty far here. We can find it at some point. There you go. Is 21 an outlier, right? Who knows? Maybe 21 is an outlier, maybe it isn't, is what we're trying to figure out. But then they want to know, well, where's that cutoff line? Maybe would 19 be an outlier then? That's what they're trying to figure out. How do I know? Right? What is an outlier is basically what they're saying. Is there any kind of mathematical way that they decided to say, you know what, no, that's an outlier. So how do I know? All right, point is, there must be a way to actually tell if something is an outlier. That's just not some subjective, like, yeah, sure, it's way out there. That's an outlier. So to find an outlier, you first must find the interquartile range. So you take your Q3 minus Q1, and in our problem, that would be the 13 and the 5. And that last problem that we just did, and if you don't remember, go back to the video. Hopefully you have it saved in your calculator. You can go back to the last video and plug those numbers in. But the interquartile range is 8, right? And then you take 1.5 times that, which in our case is 12. So now, here's what you do. You take that 12, right, that you just found, the 1.5 times your interquartile range. You take that 12, and basically what they want you to do is you take your first quartile and you subtract that from it, and then you take your third quartile and you add to it. That tells us that anything higher or lower than that, right? So if your quartile range, right, you have that quartile range, tells us that anything higher or lower will be an outlier in this problem. All right, anything higher or lower than that will be an outlier. So for example, 5 minus, because that's the quartile range, 5 is the first quartile, minus what we found is 12. So anything basically below -7 will be an outlier. Well, our data was not below -7. We don't have to worry about that. Then you take the third quartile plus that, which is 25. Anything above 25 would be an outlier. Our highest value is 21, so we're okay. Nothing to worry about. Therefore, anything outside of -7, so like a -8, -9, -10, or anything outside 25, like 25, 27, 100, those would be outliers. And thus in our problem, 22 is not an outlier, so it wouldn't matter, right? 21, not an outlier, right? Anything above 25 would be. So let's recap. Given a raw set of data, often we cannot detect a pattern. Perhaps some values happen more frequently, right? Maybe some extreme values stand out here and there, right? Maybe you can see the range of values by looking at it. The presentation of data, including summarization and descriptions, are very important. All right, box and whisker plot can help kind of put the data in a picture form, so you can kind of look at it and see what's happening. Some of these descriptions of the data, you got average values, right? Measure of dispersion, positions of various values, right? The shape of the distribution is important, right? These are all examples of what we call descriptive statistics. Again, if you got to pause the video and write this down, these are all descriptions of the data, finding average values, finding the positions of certain things, finding how it's dispersed, what the variation is, the shape of the graph. These are all descriptive statistics. And descriptive statistics contrast with statistical analysis, which is the process of drawing inference from the limited data, getting conclusions from it. All right, is basically what we're saying. Statistics contrast depending on what you're looking for. So, recapping some stuff basically is what I'm doing here. I'm trying to go back. I'm trying to recap. All right, I'm trying to figure this stuff out. Again, kind of like bought back through. Measuring of the center, finding the median and the mean. We already went over this, but I like to spiral back through to make sure you guys are fully getting this. All right, the word average is used in common everyday conversation very frequently. People say average all the time. People say my bowling average or my batting average or the average life expectancy. They say this stuff all the time. Average, right? The word average is derived from the French word avarie, which refers to the money that shippers contributed to help compensate for losses suffered by other ships. All right, it's kind of neat. All right, this idea that all these ships go out, some of them don't come back, and they'd split their money. All right, kind of that idea of sometimes what people who wait tables do. All the waiters pull all their money together and they split it out evenly at the end of the night. All right, it's just what they do. Those losses were shared then with everyone contributing. All right, they were shared with everyone. In common usage, the word average has come to mean a representation or a representative score of the data. It also means the center, all right, due to some distributions. Mathematically, there are a variety of ways to define the average of a set of data. There just are. We use whichever method is basically the most appropriate for the case, okay? There are many measures of center. That's what we're talking about, the mean, median, and mode. All measures of finding the center of your data, but some are more important than others depending on the data. However, beware of that headline that reads average all the time. The writer has probably chosen the method that emphasizes the point more. I can do that. That's the fun part with statistics. You can take statistics and data and you can break it down to its most minuscule points to make it fit what you want it to fit. All right? Or I can use the best center that fits my data. So let's look at two ways to denote average. Again, the median, which is the middle number of a set of arranged numerical values in order. And then let's look at the mean, which is, again, found by adding the items up in a set and dividing them by the certain number of items in the set. So, taking a look at an example, consider the following set of home run distances in inches, right? Or sorry, distances in feet to center field, all right, in 13 ballparks. So, home runs. These are all the home runs, like those distances in feet, right? Which, if you think about it, it's kind of unfair. This park, you can get a home run and you only got to hit at 387 feet, but then this one over here, you got to hit at 461 feet to get a home run. So take a look at the example. As we're doing it, I plug all those in. What's the average? Well, we can easily find that on the calculator, right? We went over this before. So I put it in, I press stat, go to edit, right? I plug all this in. This was what was in before, so we would erase it, right? We clear it out. So make sure you highlight that, press clear and enter. And then we fill in all of our data. And again, if I'm moving too fast, you just need to pause this video. That's what you got to do and write it all down. All right? Rewind if you have to. But plugged in all the data. Press second in mode because, again, that gets me back to the beginning screen. And then it says press stat. Again, and now I'm going to go over the arrow key over one to highlight calc. And we are talking about one column, one variable statistics. I want list one, right? So I make sure it says list one. I highlight it, go down to calc, right, and press enter, and there's my mean, right? I got it, 417.3. Now what we're going to find out later, just fun fact, that the standard deviation of this is different in each, even though it's barely different, sample versus population, but notice how it's not different. They only have one thing that says the mean. We'll get to that explanation later in the course, why there isn't something here that says mu. All right, we'll get to that later. But the point is, that's sample mean. That's your mean. That's basically on average when you go to a park, what you got to be able to hit. Now, if I scroll down, the median is 414, meaning the middle of all of that is about 414. They're pretty close to one another, 417. 414 is the median, right, which is the middle. Point is, we just found the mean and the median of the data using the calculator, which we kind of did before, but you are permitted to do this on the entire test and use the calculator. I just need to keep reiterating that to you. You got to know how to plug this stuff in on the calculator. So let's take a look at the median. The word median is derived from the Latin word meaning medius, which is middle. Okay, that's where it comes from. And the values under consideration are arranged in ascending or descending order. In order is the point. And if there is an odd number of values, again, remember the middle, right? That's our median. And if there's an even number of them, we said you add them up, right? And you divide by 2. And whatever that number is in the middle is what you get. Remember, you got to put these numbers in order. That's how you're going to end up getting them wrong. The median is not affected by exactly how large, all right, or the larger values, right, but it's affected by exactly how large the larger values are, or how small the smallest values are. Point is, in a data set that we just saw, the highest was 461, right? Well, the point is, I could have replaced 461 with 812 feet, and it's not going to affect the median, but the average would be drastically skewed by that outlier, and we went over that stuff before. Thus, it is a useful measurement when the extreme values or outliers are looking kind of suspicious, which is why before we talked about home values, right? We said it's the median of a house, the median price of a house, not the average price of a house. Or income, for example, you talk about its median income, not its average income, because they'll get swayed by outliers. And that works for both low and high. So for example, if 10 mice try to solve a maze and 9 succeed in less than 15 minutes, but 1 still tries, and it takes 24 hours for that mouse to escape, the median is going to be unaffected, right? It's not going to, the mean though would be, because now I got to put that in 15 minutes for every other mouse. Oh, this one, all right, that's a lot of minutes. So when I average it all together, yeah, it's not going to look too good when we average it out and say, well, on average it takes the mouses, where it's false. No, this mouse was just an idiot, okay? It got stuck somewhere, couldn't get out. So you take that and you could throw the outlier out, but the point is the median would be a better measure for this problem. If salaries of 4 executives are each between $240,000 and $245,000, but that 1/5 salary of that executive, all right, is $20,000, because it's a small business person. He's the executive of a small little business. Again, the best representation is the median, because everyone else is way up here. You don't want to drag all the values down. All right, it's not what you want to do. It throws off the middle. That 20,000 will throw it off. The median is resistant to extremes. That's the point. All right. In certain situations, the median offers the most economical and quickest way to calculate an average, is basically what that does. Right? For example, suppose 10,000 light bulbs of a brand are installed in a factory. Actually, you know what? I'm going to stop right there because I think we're diving into some more problems and I don't want to race through them. When we come back, we'll start with some more examples of differences between means and medians again. And again, I like to spiral back through. That's my job on this course, to kind of keep hitting on this stuff throughout the chapter. I don't want this stuff to go away. The more you see it, the better it's going to be.